Hello, this is a short video to introduce a simple app I've written using Claude AI to introduce basic kinematics. The link to the app, which is hosted on GitHub, is given in the usual place below the video. Also, if you feel you want or need some help or support with pre-university mathematics, you can contact me, again using a link below to my email address. So what is kinematics about? Well, kinematics is part of mechanics. It's about the motion of particles. And when we first come across it, we try and simplify the situation as much as possible. So we think about an object as what we call a particle. And that particle has a few properties, but we ignore most of the properties of a real object. So what we're interested in are basically two things. One is the location of the object, and two is the mass of the object. But even for kinematics, the mass isn't important. We're measuring or we're calculating properties of the motion of the object moving in a straight line or in one dimension. And those properties are, where is the object? And how fast is it moving? And is its motion somehow changing over time? Now, those properties have particular names and particular definitions in kinematics, and I'll introduce them and show you some applications of those properties and how to calculate and answer particular questions in one-dimensional kinematics. There's going to be a separate video very similar to this one, related to a very similar apps, but takes this idea of one-dimensional kinematics or movement in a straight line and applies it to two-dimensional kinematics, or what we call projectiles. As I said earlier, kinematics is about the motion of objects, where we only have to measure or calculate some very basic properties of the motion of the object. For these kind of questions, we don't even need to know the mass. That will come along later. And as I've said, we talk about particles, where we're interested in the position of the particle and how does it move. At the bottom of the home page of the app are links to some subsidiary pages, and let's go through them in order. So what are some of the basic ideas or concepts around kinematics? Well, this idea of motion, where an object starts in one place and moves somewhere else. And some of the things that we can measure is how far has that object travelled, or what's the distance it's travelled. Also, we quite early get introduced to the idea of speed. How much has the distance travelled over a particular time? And if it travels a further distance over a certain time, we say it has a higher speed. And if that speed is itself changing, then we say the object is accelerating if it's getting faster, or decelerating if it's getting slower. For kinematics, we make that idea of motion and speed and position and distance a bit more specific by introducing terms such as displacement and velocity, and we still use acceleration. And the main idea is that in addition to calculating those quantities, we also have to add the direction that that change is happening. So if we say an object has moved 1 meter, for kinematics we immediately say, well, has it moved 1 meter from my left to my right? Or has it moved 1 meter from down here to up here? So in kinematics, the direction of the change, the direction of the velocity, the direction of the acceleration is in some ways as important as the amount of the change, the amount of the distance moved, the amount or value of the speed, which now becomes the velocity. When we talk about an object moving with constant speed, it's moving with a motion such that it covers the same distance in the same time. But for velocity, we need also to say which direction that motion is. And in this animation, the object is moving from left to right. Further than that, we need to add numbers so we can do some calculations. So we have quantities such as the displacement from the starting point, and that is represented using the letter S. And the displacement is related to the time. Where is it at a particular time since we started measuring? Now we can use kinematics to tackle slightly more challenging situations, like an object falling down under the influence of gravity. And here, if we take careful measurements, we notice that for each second it drops, it covers a progressively larger distance. So in this animation, it's covered 1 distance unit, or s equals 1, in 1 second. And then 4 distance units, or s equals 4, in 2 seconds. And 9 distance units, or s equals 9, in 3 seconds. So it's not moving with a constant velocity, because the amount of distance it travels in any particular time interval is changing. It's accelerating. And an object can also be accelerating as it moves horizontally. Either it moves left to right as far as I'm watching this animation, or left to right as you're watching it. And again, we still use the same variables like s and t, and we can calculate values such as its velocity v or its acceleration a. Now when we answer a question in kinematics, how do we know it's even a question about kinematics? Well, often there are particular key words that will indicate we can probably use the techniques that are summarized in this app, such as constant acceleration. Now, constant acceleration is vital to be able to use these techniques. If there's not constant acceleration, we have to use other techniques for which there is a different app and a different video. But also the question might say the object starts from rest or starts moving from rest, or it comes to rest. And some of the values that we're measuring or calculating, such as its velocity, will be measured using units such as meters per second. Remember that we must also be very clear as to which direction the object is moving. And we soon come across questions where its acceleration can be in the opposite direction to the direction that the object is initially moving. And we'll come on to that. The notation that we're familiar with are the letters S, U, V, A and T. And they're defined here. When we come on to two-dimensional motion, either motion of an object moving through the air, a projectile, or an object moving on a flat surface on a plane, then we can extend this notation by having 2 axes of movement. Let's call them X and Y. And then the variables S, U, V, A will all have a suffix X or Y, indicating in which direction we have that displacement or that velocity or that acceleration. Notice there isn't a subscript for time because time doesn't have a physical direction, although we can think that time is always moving forward. The standard kinematic equations are given here, and it can be useful to learn them so that when you come across a question, you can start to think, well, which of the 5 equations can we use? Another useful thing to think about is that any equation has 4 of the 5 variables in it, and then that's why there are 5 different equations. And to answer a particular question or particular part of a question, you need to know 3 of the 4 values in order to calculate the 4th unknown. So if we take, for example, s equals vt minus a half at squared, the third equation in the list, which tends not to be used but can be useful and speed up your solution, then for example, if we know values for its displacement from the origin at a certain time, its velocity at that time, the time it took to get to that point from the origin, then we can calculate the acceleration. And any reorganization or rearrangement of any of the variables in any of these equations. Drawing diagrams in any mechanics question is really a vital activity, and some of the things that you need to include in almost any mechanics solution will be the axes, the direction that the object is moving. Now when an object is just moving in a straight line, you only need one axis. Let's call it the x-axis. If the object is moving in two directions at the same time, such as far as I'm concerned, from left to right, or as far as you're concerned, from left to right, the object is moving vertically and horizontally at the same time. For example, let's consider a vertical column. Now it might turn out that the best way or most straightforward way to create our axes is at the bottom of the column, and we might have a horizontal axis along the ground, which we simplify as being completely flat, and a vertical axis from the point at the bottom of the column, where the column we simplify to be perfectly straight and perfectly perpendicular or at right angles to the ground, and we might label that axis Y. When we come on to more complicated situations, then for example a slope or an inclined plane, we usually, because it makes the maths a bit simpler than if you use other approaches, but ultimately any approach applied correctly will give you the correct answer. The usual axes chosen are first of all parallel to the plane, and then at right angles are perpendicular to the plane, where the start point of the axis or the origin of the axis is where the object has started moving from. And if we take a one-dimensional example, we could say we're just interested in the object dropping just from the side of a vertical column, and because it's moving downwards, I've chosen to make downwards my positive direction, and it starts with a displacement 0 because that's where we're measuring from, and the initial time is 0 because that's when we start measuring the time, and its initial velocity, if we release it from rest, is u is 0. So very early on in the question you have to establish where are your axes, which direction are they in, what quantities does the object start with, and does it start at the origin or does it start somewhere away from the origin? And a diagram will really help you get those quantities and give them the right values and give them the right sign. You'll devise your own method for solving these problems, but the important thing is to be systematic and to do the same steps in the same order, because that will probably work for any one of these kinematics questions. So as always, read your question first, identify the information given in the question, then draw a diagram and explicitly list the quantities, the values that the question gives you, either in terms of numbers or sort of in code, like it's falling under gravity, well that tells you the acceleration, or it comes to rest, that tells you that v will equal 0 for this part of the motion. Then identify what value you're being asked to calculate, and from the known information and what you're asked to calculate, go and find which equation combines all that information together, then substitute your values and solve it for your required value. And then finally check your answer in the sense of, does the quantity itself make sense? And that takes a bit of experience and a bit of judgment to know whether or not you have a sensible answer. And that will come by practicing and trying different but similar questions. I won't go through the standard results in detail, and sometimes you might be asked to determine the acceleration or the height an object reaches when it's thrown in the air. Or for example, the time it takes from when you throw it from the ground, it reaches its highest point and then it hits the ground. Or the total distance it travels from being thrown up and hitting the ground. On these pages, if you click on any of the Learn More links, then the detail of the algebra is given here. In all of these where there are hidden working or hidden solutions, I really recommend that you try and solve the question yourself, get as far as you can, then click on the link, see where you've got stuck, and then close the link and try and finish the question. And then next time when you come back to it, as you always would do, try it again. See if you can get a bit further in the solution, and slowly by repetition, or quickly if you twig the answer, you'll get to a point where you don't need to look at the solutions, but you can use the solutions to check all your working. And finally, here are some standard worked examples where we're using some of the different equations in different ways to calculate quantities like displacement or acceleration, or the speed with which an object is projected, its initial velocity. Again, here's the question, here are some of the quantities, and then the solutions are all given here. Well, I hope you find the apps useful to reinforce or understand the basic ideas of one-dimensional kinematics. The link to the apps is given below, and if you want some personal help or just ask some questions, send me an email on the link given below the videos. Good luck.